All right, so welcome to the podcast. We have Cale Teeter again. Cale, you want to introduce yourself?
Sure, this is Cale Teeter. I'm part of the blockchain engineering team at Microsoft here and a friend of Razi's.
Awesome. So, end of May, Blockchain Week, Microsoft built a lot of announcements related to blockchain. How would we talk about some of those services and features that we released? I know that we have a big announcement around blockchain as a service with the support of managed ledger, supporting JPMorgan Quorum. We have the Visual Studio Code extension that came out that help programmers and developers to basically code against blockchain. And then we also have an announcement around the CCF, which is basically Confidential
Consortium
Framework. Yes, so rename that. So we're going to talk about all of that, but how about we start with the blockchain as a service, the managed ledger?
Yeah, so to give the listeners a little background here, for those who might not be aware, in the blockchain space, Microsoft's been involved for quite some time, many years now, and initially, the offerings that we were working on was to enable and make it easier for people to spin up the infrastructure for blockchain. Because early on, I'm talking back in the 2015-16 days, it took quite a bit of time to even spin up the infrastructure to even start working with this tech. I think we've come a long ways since then, but back then the idea was, can we leverage the cloud and some of the cool stuff we have in Azure, from compute, storage, the security tools that we have inside of Azure, to make it easier to spin up these networks. And so we developed a series of templates and worked with a lot of the leading partners. Razi had mentioned Quorum as one of the leading partners, but there was many others, just regular Ethereum, Hyperledger Fabric, Corda, a bunch of different ones, all the kind of leading ledger technology. And so we spent some time building those and getting those out there. And then what we kind of realized after that was, people need to build things on this. So we released a product called Workbench. I think it was more than a year ago. And that was targeted at proof of concepts, still targeted there. We still support that product. We actually just had a release for that of 1.7, which supports the managed ledger now. And essentially that's there for POCs. But then after that, we kind of are working on how do we get to production. And one of the things around production is, we need to have things like this managed service available for folks who don't want to actually have the nodes in their control. So the managed ledger concept is essentially the nodes that are running your blockchain network for a consortium, for a particular member of a consortium. Let me define what that is. So a consortium is a group of businesses who are going to work together and build a blockchain.
Got it. So basically, here's what I'm hearing. So we have this blockchain as a service. We launched it a couple of years back. We have the consortium network support that we've been used for a while. Now we are enhancing it.
Yeah.
We're adding more features to it, and this new feature that we released this month is the one that supports the JPMorgan Quorum, which is a fork of Ethereum, if I'm not wrong. And then,
okay. So this is referred to as Azure Blockchain Service. So there's a bunch of different terms thrown around here. So when you hear Azure Blockchain Service, that's the managed ledger, and currently it supports Quorum. But it's an open architecture, so we can support other chain technologies or ledger technologies in there. Quorum is one that we partnered very closely with, and so they're the first to be on that platform.
Got it. So the idea is that in the future you can see more.
That's correct.
Okay.
And the idea here was take away even more of the burden of running these nodes and have essentially Microsoft is running those nodes on behalf of the user. So you're getting back basically an endpoint that you can work with. The health of all those nodes that are running up there is totally managed as a service by Microsoft. So you can think of it a bit more like a PaaS service.
Okay, good. So how about that we share some of these, like we can show what this looks like.
Let me show you what this looks like in the portal. Okay, so what you're looking at here is the Azure Management Portal, for those who don't know. If you just go to portal.azure.com, you'll be able to get to this. And essentially what you see here is a consortium that's already been spun up. But let me even take a further step backward and say, hey, here's what it looks like as you're essentially creating one of these. So from a managed ledger perspective, you can see it's literally one page. This is all the stuff that you have to answer to spin up a Quorum network and be a member on that network.
So I think the idea here is that organizations and people who know Quorum, right, they wanted to go and wanted to have an environment, like a full network, we're basically providing that space for them to spin up.
Yeah.
So basically that they don't have to go through that laborious process themselves, and that's the underlying value.
That's right. So essentially, you can see it says blockchain member. So in a consortium, which is a group of companies that are businesses that are going to work together, each one of those will consider them to be a member, right? And in a member, you'll have transaction nodes. So I won't go through. You can fill this out yourself. Like you can go spin one of these up. But this is what it looks like once it's spun up. You basically have a consortium here. Inside of there, this is a member. So you can see my member name is right here. Under there, we have transaction nodes. Now, in my case, I have two. You can have, others here as you like. And in these members, these are the transaction nodes that we're actually going to operate against. So you can see that there's some specific integration we've done here with Quorum. So you can see the public key is shown here. So for those who are familiar with Quorum, we can do private transactions, not just public transactions. What that means is, like in a consortium of a group of companies, if I send a public transaction, everybody can see all the details. If I said, in this case, I only want to share data with a specific member on the blockchain that's part of my consortium, then I can use this public key. So I would share this, particularly like with Razi. If I said, hey, I want to do a transaction with you, and we want to keep it private, I would share one of these public keys with you. You would use that when you do your transaction, and that keeps it quiet from the others that are in the group. And then if you drill even further into these transaction nodes, you can see how you actually authenticate to these things. So you have basic auth and you have your access keys and everything in here in order to access it. So basically what we're doing is giving you those endpoints back that you can then use to come operate against this blockchain.
All right, so this is something that you spin up and is ready to go. Like is there anything else we need to know?
No, other than essentially, you can pick the sizing on this thing. So if I went back to the overview here, there's different pricing tiers here. And this will basically judge like how many compute codes you have, how much storage you get, all those kind of things. And you can pick the standard and basic, and those things will get extended. This is in preview right now. So essentially, we're still adding features and things here, but come take a look at it. This is some of the features right now. But yeah, it's pretty much hands off. Like you can control the security around who can access this as part of your stuff, and that's pretty much it.
Great. So I think that's a good new addition. So from a developer standpoint, like to say you want to write a smart contract, you want to do the development. So for Microsoft Visual Studio Code is something that we've been heavily invested in, and I know that there is an announcement around an extension. So I want to talk about that. What was that about?
Yeah, so beyond, like we just talked about, a lot of infrastructure stuff there, so running these ledger technologies, nodes and things up there. But beyond that now, people need to do stuff with it. And I mentioned before that we worked with a product called Azure Blockchain Workbench, which is still available, still widely supported, allows you to do quick POCs and be able to demonstrate these kind of things to your company that things actually work beyond just like a terminal window and actually help you create applications. But if you take that step a little further, like, okay, I want to go into production. When we get into production scenarios, now we need to talk a little bit about the developer experience. And what I want to show you here is something we've been working on and we released again in preview at Build. And so what you're seeing here is just vanilla, VS Code. And I basically have an extension installed. So when you look at the installed extensions I have here, you'll see the Azure Blockchain Development Kit for Ethereum is right here, and has lots of good documentation. So you can go look, and it even has some like animations here to show you how to do some of the stuff I'm going to show you right now. So come check it out. You can just literally search inside VS Code. So if you click on this little thing here and look for blockchain, you'll find us in there. You can see right here is our guy, and I already have it installed, so we don't need to go through the installation. But basically what we tried to do here is connect what we did with the Azure stuff. So we have the infrastructure components, and now we actually want to do something with it. We want to be productive as a developer. And so what we did is build this extension that allows you to do a bunch of things. And if you type Azure Blockchain in here, once you have it installed, you can see there's a whole series of commands that you can do here. Things like Ganache, and I'll explain what these are in a minute here, and a lot of consortium stuff, and along with this new Solidity project. So the idea was, file a new project for a user. People need to come into Visual Studio and say, hey, I want to be productive and build an Ethereum-based application. I can click on this new Solidity project, and you see it's activating the extension because I didn't open anything yet. And eventually we'll get a little dialogue here. And actually you'll see this little view that we created here, which actually connects to our Azure Blockchain Service that I mentioned earlier. We'll talk about that here in a second. This is in preview, so you'll see a lot of debug messages coming back on the output here. Once we go GA, some of that stuff will be alleviated, but we put that out there for now to help developers. But the idea is you can see that now we have basically a basic project or truffle box. We'll just handle the basic case here today, which is basically just create me a new Solidity project. And I got an empty folder here. Now what's going to happen behind the scenes is going to go download one of our templates for Solidity that basically will scaffold out all the stuff that you need for configuration. It'll give you some sample smart contracts, all that kind of stuff.
Got it. So the idea here is that just make life easier, right? Like for other outside blockchain, I know that we have a lot of templates already in Visual Studio Code. So the idea is that to bring the blockchain to the developer, to make it easier.
That's right. Yeah, we want to make it approachable for people who are new to the space, but we don't want to get in the way of people who are really advanced. So we've been pretty cognizant about how we build this extension so that advanced guys can do what they need to, drop to a terminal window, do whatever they need to. Guys who may not know what they're doing as much, we want to kind of guide them along that way. So you can see we basically scaffolded out a project now. We have a Hello Blockchain smart contract out here. You can go look at it. It has some events and things in it, just some basic stuff. Now, what we did also is integrated into the context menu, so you can see we have other options here beyond just the normal VS Code stuff. We have things like build contracts, deploy contracts, a bunch of things about generating kind of microservices and things. So if I do a build here, what we're actually doing behind the scenes is going and compiling that smart contract. So again, I didn't have to download anything. I didn't have to go through any like GitHub things and pull other libraries and things like that in, which in the open source world, there's a lot of stuff that's available, but it's hard to find it sometimes. And so what we're trying to do, so you can see the compilation finished. We got this build folder with our output here. And then essentially whenever we do a deploy, we're basically saying, hey, do you want to deploy to a local machine like a development? Or do you want to deploy to this consortium? And the reason it knows about that is because I registered my consortium down here.
So this is the same consortium we saw early on, which is basically backed by the Quorum network, right?
That's correct. Yeah, so this is the same exact one we saw in Azure. We just see it reflected back. For those eagle-eyed, you can see down here at the bottom, I'm actually signed in. So if you weren't signed in, it'll basically prompt you and say which Azure account and subscription do you want to sign into, and then it all works kind of seamlessly. If I deploy locally, as a developer, I'm on a plane, I just want to get some stuff done, I'm not even connected to the internet, I can do that. So right now it's doing the migration to my machine through an emulator. We're actually using the truffle technology underneath here. So you'll see a lot of stuff around truffle over here. You'll see in the menus, and you can see in the debug output, we're doing a lot of stuff with truffle.
Yeah, that's true, because when a lot of developers work with Ethereum-based smart contracts, they just have the local, like a Ganesha network running, like a local hosting, right?
That's right.
And then once you're done there, you wanted to go to the next level. The typical, the one environment, and then the higher environment, and then you go through the entire pipeline. So that comes baked in, like it's already there. If you don't have your Azure Blockchain as a Service running, you can complete your testing on the local environment, and then you can basically connect.
Yeah, you can actually, if you do a connect to consortium here, you can see local Ganache is even here too.
Yeah.
And if I put in 8545 here, you'll see it actually registers here. And what's cool is, like, by default, you notice I didn't do a bunch of stuff to start Ganache. Ganache is, as Razi mentioned, it's a tool from the Truffle suite. Great partner of ours, and it essentially allows you to emulate a blockchain locally, like in memory. And you'll notice that now you can do stuff like stop or start the Ganache instance, because essentially we started it automatically for you. When you said, hey, I want to do a deployment locally, we said, oh, fire up Ganache. So again, just trying to lower the bar to entry for people that don't have to go download these tools.
This is super cool, because the people who work with like Docker or Kubernetes, they have the same thing, like a Minikube. And then you have a higher environment like Azure Kubernetes as a Service. It's a similar concept, like exactly the same, pretty much.
Yeah.
For blockchain.
Exactly. Trying to keep it the same, so people understand what they're doing. So if we hit deploy here now, you can see that we also have our consortium that's in Azure. Now it's a little different, right? So when we go to one of these consortiums, we now have to sign transactions, right? So in Ganache, we were afforded some luxuries of not having to do some of the same things we do with a public network or a real private network, where we actually have to sign. Everything that goes on the blockchain, for those who are aware, has to be digitally signed, right? And so when we do that, typically this is another bar to entry to users. They'll say, oh no, what do I have to do here? Well, I have to get a wallet, then I have to like figure out how to use this thing, and I have to like sign my transactions and I send them up to the blockchain. It's like a multi-step process. So we're saying, let's make that a little easier too. So you'll notice whenever I try to deploy to Azure, I need to actually sign the transaction. So it says I need a set of keys. And so you can see I have some saved here. We basically just truncate the mnemonic. A mnemonic is just a series of words that are used as essentially you can think of as like a password. And so basically I have some that are already stored that were generated. If I wanted to generate a new, I can hit generate new here. It'll create a new file in my file system. I can point to wherever I want to have that thing stored. I can also paste one in here if I had an existing mnemonic I want to use, but I'm just going to use one that I already had. And I'll show you what the magic is behind the scenes there, but essentially we took that mnemonic, used it to generate an account, and we're using that to sign the transaction. So we're signed basically our contracts here, and we're sending those up to our consortium. You can see it's going through here in the output window. This stuff is actually pushing live to Azure right now, as you see it. You can see our little status down here as it's deploying. And after a few, it takes a little bit longer, obviously, because it's going over the network.
So it basically created an account for us. It basically done the deployment for us.
That's right.
Behind the scene.
Again, you notice I didn't write any code. I didn't do any touching there. The magic of how that actually happens is in, again, Truffle is the engine behind this. But basically what we're doing is this. If you look in the Truffle config, and for those who already experts know, this is where all the meat is of how you push to different networks. So here's my development network for Ganesh. That's in there by default. You'll notice this was not in there by default. And what we did is initialize it, and you can actually see I'm pointing out to that file that I picked in UI in VS Code. So I'm initializing a wallet provider using that mnemonic, and then essentially I'm going to my blockchain network, which is this URL over here. So we get that from the Azure portal, or you can just get it here, right? So as I connect up here, if I say connect to a consortium, I could say Azure, and you'll notice it'll start going in, what's your subscription, what's your resource group. So it'll walk you through basically making that connection. So you can have many of them down here. Think of them a little bit like a database connection string is really what we're after. So you can register stuff here, then you can use it in your project up here.
Great. Now, one thing that comes to my mind right now, I just want to quickly touch on it. So basically, this is sensitive information though, right? Because this is confidential, the mnemonic. You don't be like, so is it like secure, like how we are storing it?
Yeah, that's a good point. So the mnemonic itself is essentially a series of 12 words, like we said before. We let the user, in your case you, store that wherever you like. So you can put that on a USB drive, you can put it anywhere, preferably it is sensitive, as Razi mentioned, and so you would probably want to keep that relatively secure. You don't want to just like put that anywhere on your file system. But basically, the idea there is we're looking to improve on that as we go forward. But for now, we basically just let the user choose where they want to store it, so that we're not holding your keys kind of thing. Yeah, and the thing is, it's really powered by our partners here. So you'll notice that we've been working with the Ethereum Foundation. If anybody tuned in to Build, you saw Vitalik was actually there with our CTO of Azure, Mark Rusinovich, on stage. And so we've been working with the Ethereum Foundation for quite some time and continuing to work with them to help define how this developer experience is. The Solidity plugin from Juan Blanco, for those who don't know, it's been out there for many years. And if you notice, whenever I was in here using the smart contract, how everything's color highlighted and spaced right and all those kind of things, it actually has the keywords in here and stuff. So when you're typing things, you can see it actually reflects like the Ethereum syntax here, like it's a linter there. And so that's powered by Juan Blanco. And so the idea here is that we're trying to take the best of breed here, and Truffle Suite obviously as well. So we're trying to take these partners who are really driving the ecosystem and get them more exposure, right?
Yes.
We want to connect them with customers because Microsoft can build some technology, like the Azure services and things that you see, but there's also a whole ecosystem of open source developers, and we want them to be as connected in here as possible because they're building great tools as well.
Fantastic. All right, so one more announcement to go here. CCF. What is CCF?
CCF, Confidential Consortium Framework. So this is something we've been talking about for quite some time now. And essentially, what we did is kind of the next step with what we've been doing here. Some people may have known in the past we had this word called COCO. But the new name for this is called Confidential Consortium Framework, which is a completely open source technology that's showing how we can leverage the power of, in this case, Ethereum. So this is based off of Geth. It's a fork of Geth. And essentially what it does is allow you to use these trusted execution environments in the blockchain. So last November at DevCon, which is the big Ethereum event, we showed and open sourced the EEVM, which stands for Enclave-Based EVM. And what that is, again, is a fork of Geth, the popular client that's used for Ethereum. it's been rewritten a little bit, and it's been used to kind of build this trusted execution environment. And what this allows you to do is do a lot of different things. So the trusted execution environment really affords us a lot of opportunity for doing things like making the blockchain transactions faster, influencing how things can happen here. Because if you think about it at the core, things like that happen in Ethereum today, essentially there's a distributed mechanism or a decentralized mechanism that's happening there. Like if I have a smart contract, we call a function on it. It's got to run on all the nodes because I don't trust if one of those nodes has been compromised. But what if we can have some trust in that? How can we build trust around that? One of the ways is to have this trusted execution environment. So if we have the trusted execution environment where we have code operating, essentially we have some assurances around what environment that thing's running in. So the chip itself, has it been tampered with? Has the firmware been messed with? And the code itself. So as the code is coming in there, it's also been, quote unquote, code signed kind of thing. So now we have some assurance and no one's messed with the code that's running there, and we know the environment's good. So we have strong assurance, and we can make some certain assumptions now about the network to make things go faster.
And I believe that last time when I heard about this, there was another demo where because of this, because the way we structured this, right, with the enclaves, you get the higher assurance. You also get a good throughput, I guess.
That's correct. Yeah, because of the some of the inherent trust you now have in the system, because of what the trusted execution environment is bringing, then you can make some assumptions around what we can do there. So I think that's the biggest thing, that's kind of bringing with that. We also talked about some integration we've been doing with Quorum with CCF, and so that's one of the ones that's been integrated. You can see how we did that integration. So you can think of it from this perspective. In Quorum, for those who are familiar, as I mentioned before, we can do public transactions and private transactions, all handled by the Quorum protocol. We've basically added the CCF one too. So now you have 3 ways that you can do that transaction, not just a public and private. You can also do a CCF transaction, which allows it to run in this trusted execution environment seamlessly. And so we think
is that
really cool.
The Ethereum virtual machine itself is running in that enclave?
That's right.
Okay. So, and then I believe is it a fork or is it the optimized version of it?
Yeah. It's kind of rewritten a little bit in C++. And again, the code's all out there. You can go look at it. We can include the link in the link dump for the folks here.
Yeah.
But it's based on the Open Enclave SDK, which also is open source. So for those who are interested in this tech, you should go take a look at that. There's a great walkthrough. So the secure enclaves that exist in Azure, they do exist today. They're DC series VMs. Mm-hmm. And so basically you can go do this today. You can go check this out. We actually have a nice little walkthrough of getting started with this up there. And you can experience the whole thing for yourself.
Awesome. So this is another announcement that came out. All right, so the resources link is going to be down there in the description. And I think we should come back and we should do a little more hands-on next time.
Yeah, I think there's tons of stuff that just got released, as Razi said.
Yeah.
It takes a little time to kind of digest this, so we wanted to give these in a little series here.
Yeah. Awesome, thanks. Okay, goodbye.